Imagine waking up one morning to find your GPS acting weird, your phone struggling to hold a signal, and satellites falling silent. At first, it seems like a tech glitch, but then the news breaks. Something deep beneath our feet and in the skies above is changing, quietly, relentlessly. A global phenomenon that scientists had been monitoring for years has suddenly accelerated. And at the heart of the chaos lies a strange magnetic anomaly, one that may not be natural at all. For decades, scientists have been tracking Earth's magnetic field, our invisible protector against solar radiation and cosmic particles. It's this field that allows us to live safely on the surface of this planet, shielding us from the harshest elements of space. But now it's faltering. And deep in Europe, at the most advanced particle physics lab in the world, something even more disturbing has been detected. An inexplicable magnetic shift that defies every model and prediction. It happened beneath the ground at CERN, home to the world-famous Large Hadron Collider. The implications? Potentially catastrophic. CERN has always been a place of mystery and awe. It's where the elusive Higgs boson, the so-called God particle, was discovered. It's a facility so powerful, its magnets generate fields more than 100,000 times stronger than Earth's own. When two particles are accelerated to near-light speeds and slammed into each other inside the LHC's tunnels, they recreate conditions just fractions of a second after the Big Bang. But in 2023, something different happened, something that even the scientists there couldn't explain. It began during a routine high-energy experiment, one that had been simulated hundreds of times. But this time, multiple sensors across the collider picked up an unusual fluctuation, a strange oscillating magnetic pulse, irregular, persistent, and utterly unaccounted for. At first, the team thought it was an error. Maybe a sensor had malfunctioned. Maybe a power fluctuation had caused interference. But as they checked the data, they realized this wasn't a glitch. It was real. The anomaly had occurred simultaneously in multiple detectors across different quadrants of the collider. And what was even more chilling, it didn't stop when the collider powered down. The field lingered, like a ghost echoing through the facility. News of the anomaly was initially kept under wraps, but leaks happened, and soon independent researchers and physicists began poring over the scant data made available. Some dismissed it as a localized magnetic wave, unrelated to any broader event. Others, though, those working at the fringes of accepted science, began drawing connections. They pointed to another anomaly halfway across the world, the South Atlantic Anomaly. This region, stretching from the southern tip of Africa to South America, has puzzled scientists for decades. It's an area where Earth's magnetic field is unusually weak. So weak, in fact, that satellites passing through it often experience malfunctions, unexpected shutdowns, or total system failures. Even astronauts aboard the International Space Station have reported strange sensations and increased radiation exposure when flying over the region. And recently, the anomaly has been growing, splitting, morphing, as if the planet's magnetic shield is tearing at the seams. Could it be a coincidence? Maybe. But then came the timing. The magnetic pulses at CERN were detected just as the South Atlantic Anomaly underwent another sudden shift, expanding dramatically and affecting satellite operations more severely than ever before. The overlap was impossible to ignore. Some scientists began whispering about resonance, about how Earth's own magnetic field might be subtly in sync with the artificial magnetic fields created at CERN. Could the LHC's incredible energy output, designed to explore subatomic particles, somehow be influencing Earth's geomagnetic system? The mainstream consensus remains skeptical. The collider's magnetic fields are supposed to be confined within the superconducting loops of its structure. They're not supposed to reach beyond its walls, let alone affect the planet's crust, mantle, or core. But the anomalies continued. And then came the models. Simulations run by a group of physicists in Germany revealed a disturbing possibility. If Earth's magnetic field continues to weaken, and if certain human-made conditions act as external stimuli, it could trigger what's known as a geomagnetic excursion. Not a full reversal of the poles, but a chaotic, unpredictable shift in which the magnetic field fluctuates wildly, collapses in places, and rebounds in others. During such an event, the planet's shield could drop to as low as 10% of its normal strength. The consequences? Catastrophic. Without a stable magnetic field, Earth would be exposed. Solar storms, normally deflected by our magnetic bubble, could directly strike the surface, knocking out electrical grids, disabling satellites, and causing chaos in navigation systems. Planes could be grounded, communication networks could be fried, massive power outages could ripple across continents, and it wouldn't just be a matter of hours or days. A weakened field could persist for decades, even centuries, leaving us vulnerable to every solar flare and coronal mass ejection hurled our way. And so, the question began to take shape, not in academic papers, but in whispered forums, late-night YouTube videos, and independent think tanks. What if CERN, unintentionally or not, was involved? What if the high-energy experiments conducted at the collider had triggered something? A ripple, a resonance, a perturbation deep in the Earth's core that we barely understand? After all, our understanding of geomagnetism is still primitive. We know the basics. Molten iron and nickel churning in the outer core create electric currents, which in turn generate our magnetic field. But the exact dynamics are far more complex. And if a man-made experiment introduced a new variable into that chaotic system, even a tiny one, it could have unforeseen consequences. Back at CERN, the scientists are cautious. They insist there is no danger, that the anomalies are being studied, that safety protocols are in place. But privately, some admit they've never seen anything like it. Some have even started questioning whether the collider's magnetic fields could, in rare conditions, breach containment. Not physically, but energetically. Like a tuning fork setting off sympathetic vibrations in another object miles away. And so here we are. The Earth's magnetic field is weakening. The South Atlantic anomaly is growing. And deep beneath the soil of Europe, strange magnetic pulses are emanating from humanity's most advanced scientific facility. Are these events connected? Are we witnessing the first signs of a planetary scale shift? Or are we simply drawing lines between dots that were never meant to be joined? But what if they are connected? What if this is only the beginning? If the events we're witnessing are truly connected, then we are standing on the edge of something monumental, something terrifying. The Earth's magnetic shield, the very force that protects all life on this planet, is weakening. And while natural cycles can explain part of it, there's growing evidence that something else is accelerating the process. Something unexpected, something possibly artificial. Let's step back and look at the big picture. Earth's magnetic field isn't static. It moves, it breathes, it pulses like a living organism. Every few 100,000 years, it even reverses. The North Pole becomes the South, and vice versa. The last full reversal happened around 780,000 years ago, and scientists believe we're overdue for another. But what we're seeing now doesn't look like a smooth reversal. It looks like a collapse, a fragmentation. In the South Atlantic, the anomaly continues to spread. It's not just expanding in size, it's getting weaker in density, allowing higher doses of cosmic and solar radiation to reach Earth's surface. Satellites passing through that zone routinely shut down or glitch. There have been reports of strange auroras appearing in places where they shouldn't, and the magnetic field over the region has dropped so low that some models are predicting localized collapses within the next decade. This isn't just a minor wobble in Earth's magnetic ballet, it's a breakdown in the choreography. And right when these cracks in the magnetic shell begin to deepen, CERN, perhaps the most technologically advanced facility on the planet, starts registering unexplained magnetic fluctuations. Not random, not noise. These pulses are structured, patterned, and above all, persistent. Now here's where it gets strange. In the weeks following the first detection of the anomaly at CERN, geomagnetic observatories across Europe and South America began noticing synchronized disturbances. These weren't earthquakes. These were magnetic tremors, ripples in the Earth's magnetic envelope that appeared to pulse in harmony with CERN's test cycles. It's as if the Earth itself was responding to something, as if it was being nudged, ever so slightly, from within. Skeptics argue this is impossible, that the LHC's electromagnetic footprint is too localized, too tightly contained, that no terrestrial experiment could influence something as massive and complex as Earth's magnetic field. But others are not so sure. One physicist who chose to remain anonymous stated in a leaked memo, "The possibility of magnetic resonance between localized artificial fields and planetary-scale structures has never been adequately studied. We may be generating more than particles. We may be generating signals. And the planet may be listening." This idea that Earth can resonate like a bell, that its magnetic and geological systems can be influenced by energetic feedback loops, is not new. The concept of planetary resonance has existed in theoretical geophysics for decades, but it was always dismissed as fringe science, until now. In 2024, a team of researchers at a small university in Finland conducted an independent simulation. They modeled what would happen if a concentrated electromagnetic pulse, like the kind produced during certain LHC tests, were to align in frequency with natural magnetic harmonics within the Earth's crust. The results? Alarming. Even a slight alignment could, in theory, create localized stress points, weakening the crust or amplifying instabilities in the core's convection patterns. In layman's terms, that means increased seismic activity and possible destabilization of the magnetic field itself. Suddenly, fringe theory didn't sound so fringe anymore, and as if on cue, strange reports started to trickle in. Birds in South America flying off course, their internal compasses scrambled, whale beachings in the southern Atlantic, migratory patterns shifting, all small events on their own, but together painting a haunting picture of a biosphere slowly losing its sense of magnetic direction. Meanwhile, at CERN, scientists remained tight-lipped, but something had clearly changed. A scheduled series of high-energy collision experiments was suddenly postponed without explanation. Staff were reassigned, visitor access was reduced, and behind the scenes, internal communications revealed growing concern, not just about the data, but about what might come next. Was CERN on the verge of discovering something fundamental? Something about the planet itself? Or had they stumbled into a feedback loop they couldn't control, one where human-made experiments were resonating with Earth's magnetic systems in unpredictable ways? To understand the scale of what we might be facing, you need to understand what happens when Earth's magnetic field weakens too much. Without that shield, our planet becomes vulnerable to solar flares and coronal mass ejections, massive eruptions from the sun that send charged particles hurtling through space. Normally, these are deflected by the magnetic field, but in a weakened state, they can strike the atmosphere directly, frying electronics, knocking out satellites, and even causing power grids to collapse. We've already had a glimpse of this. In 1859, the Carrington event, a powerful solar storm, hit Earth and disrupted telegraph systems around the world. Sparks flew from telegraph machines. Operators were shocked. Auroras were seen as far south as the Caribbean, and that was in a pre-electric age. Today, such an event would be catastrophic, crippling our internet, GPS, power systems, and communication networks. Now imagine facing something like that with a compromised magnetic shield. And imagine if somehow our own scientific experiments were accelerating that compromise. Of course, CERN denies any link. Their official statements assure the public that the LHC operates well within safety parameters, that no energy created in their collider could influence the planet on such a scale. But here's the catch. History has shown us that the greatest discoveries often begin with anomalies, with data that doesn't fit. And in the search for answers, sometimes we trigger more questions than we can answer. Remember, CERN isn't just studying particles. It's pushing the boundaries of what we know about the universe. Every collision inside that ring generates conditions that haven't existed since the birth of the cosmos. We are quite literally probing the deepest fabrics of reality itself. And if we are stirring forces that ripple outward into Earth's own systems, we may be playing with something far beyond our control. As more data comes in, a new wave of researchers is stepping forward. Geophysicists, plasma physicists, space weather experts. They're calling for more collaboration between particle physicists and Earth scientists. Because if these anomalies continue, if the South Atlantic anomaly grows, if magnetic pulses persist, if animals keep behaving erratically, then we may be witnessing a convergence of human technology and planetary dynamics, a convergence we never prepared for. And while the mainstream scientific community remains cautious, even dismissive, those at the edge of the conversation are growing louder. What if the Earth's magnetic field is trying to tell us something? What if these anomalies aren't just warnings, but the early signs of a cascade? Because once the field begins to collapse, truly collapse, it won't happen in slow motion. It may begin with a flicker, a lurch, a moment of silence in the satellites overhead, and then darkness. Not the end of the world, but the end of the world as we know it. And the question echoing in the minds of those paying attention isn't if, it's when. And why now? It always begins subtly. The soft hum of interference in satellite data, the strange silences where magnetic readings should be, flickers of auroras appearing in skies far from the poles. Then the animals, silent messengers of chaos, begin to act unnaturally. Birds veer off course in swarms. Sea turtles wash ashore in places they've never been. Migratory patterns fracture, as if the world's hidden compass, the invisible force that guides life, has gone rogue. And behind all this, a particle collider pulses underground in Geneva, quietly, relentlessly. As scientists at CERN delve deeper into the unexplored frontiers of high-energy physics, they may be stumbling across a doorway, not to another dimension, as popular myths suggest, but to a new understanding of Earth's fragile equilibrium. What if Earth isn't just a passive bystander in our experiments? What if it reacts? In March 2025, just days before the equinox, a bizarre phenomenon was recorded in the South Atlantic. An entire cluster of low-orbit satellites, including two operated by the European Space Agency, simultaneously experienced magnetometer failure. The readings didn't flatline, they inverted. North became south, and then within seconds returned to normal. The anomaly lasted just 11 seconds. But in those 11 seconds, something was different. Back at CERN, a long-scheduled high-energy collision had taken place exactly 9 seconds prior. Coincidence? To those in the scientific community still clinging to the safety of numbers and models, yes. But to those peering deeper into the patterns, the coincidences are becoming a chorus. The chorus is becoming a warning. Independent researchers, many of whom have backgrounds in magnetohydrodynamics, the study of how magnetic fields interact with plasma, are beginning to piece together a theory. Not a fact, not yet, but a dangerous idea that our tampering with forces on a quantum scale may be creating magnetic echoes. Echoes that ripple into Earth's mantle, into its liquid core, into the very engine that drives our planetary shield. It's like dropping stones into still water. One ripple may vanish, but a series of ripples, carefully timed, can interfere, amplify, distort, and maybe break something. You see, Earth's magnetic field isn't invulnerable. It's a dynamic dance, choreographed by the movements of molten metals in our planet's outer core. These movements, in turn, are sensitive to subtle changes in temperature, pressure, and, possibly, external electromagnetic interference. If CERN's experiments are creating magnetic fields that resonate at the same harmonic frequencies as certain core processes, they could be generating micro-disruptions. Imagine if you're playing a note on a piano that matches the resonant frequency of a wine glass. If the note is strong enough, the glass shatters, not from force, but from vibration. What if Earth is that glass? Some theorists suggest this could be what we're seeing. The South Atlantic anomaly may not just be a symptom of a natural cycle. It might be the fracture point, the weak spot, the point where the resonance builds until something finally gives. And the more the anomaly grows, the more unstable it becomes. Already, new regions of magnetic instability have been spotted forming near the Indian Ocean and parts of the Arctic. The field isn't just weakening, it's fragmenting, fraying, tearing at the seams. Back in Geneva, the mood has shifted. The quiet confidence that once filled CERN's corridors is now tempered by hesitation. A recent internal paper, not yet published, allegedly discusses the possibility of terrestrial magnetic reactivity to high-frequency field generation. In plain English, the Earth might be responding to us. And still, the experiments continue. Because science, for all its caution, is also relentless. Governments are beginning to take notice. In a private briefing leaked to the press, officials from the European Commission expressed concern over the unexplained magnetic anomalies coinciding with particle physics operations. They're not saying stop, but they are saying slow down, understand, rethink. Meanwhile, our infrastructure, built on a foundation of assumptions about planetary stability, is more vulnerable than ever. An electromagnetic pulse caused by a collapsing magnetic field could fry global electrical systems in seconds. We're not just talking about a loss of power, we're talking about planes grounded mid-flight, hospitals without backup, nuclear plants with no cooling, banking systems erased, society plunged into chaos, not by war or invasion, but by nature reacting to our own hubris. And here's the terrifying truth. We wouldn't even see it coming. A full-scale geomagnetic reversal doesn't happen overnight, but the initial destabilization, the snap moment, can occur rapidly. One day compasses begin to spin, the next GPS becomes useless, then satellites fall silent, and finally we're in the dark. Even now, solar activity is increasing as the sun moves toward the peak of its 11-year cycle. NASA and the European Space Agency have both issued quiet warnings about heightened risks of solar storms over the next 18 months. The sun doesn't care if we're ready. It doesn't care if we're experimenting. It just sends out its flares. And without our magnetic shield at full strength, those flares could scorch the modern world like lightning through dry brush. And still, the experiments continue. Not out of recklessness, but out of necessity. Because for all the fear, CERN may be our only hope of understanding what's really happening beneath our feet. If we can grasp the rules of magnetic resonance on a quantum level, we might be able to model, maybe even stabilize the chaos growing within the Earth. There's a theory, still in its infancy, that suggests we could create artificial magnetic reinforcement zones, temporary shields, like magnetic scaffolding to support the planet's natural field while it recalibrates. But such technology is theoretical, untested, risky, and it would require power on a scale we've never before harnessed. But the alternative? Let the field fail. Let radiation from the sun strip away our atmosphere, one molecule at a time. Let our cities go dark, not from bombs or blackouts, but from a cosmic silence, from a world without a compass. We've always believed we had time, that these changes would come in thousands of years. But what if we were wrong? What if the countdown isn't geological, but generational? What if the anomaly is not a slow decay, but a ticking clock? Tick, tick, tick. The world is listening now, not just to the data, but to the silence between the data, to the anomalies, to the whispers of a planet under pressure. Whether CERN is the cause, the catalyst, or the key, one thing is clear. We are no longer just observers of the universe. We are participants, influencers, and perhaps disruptors. The Earth is changing, its shield is breaking, and in our pursuit of understanding, we may have uncovered more than truth. We may have cracked the foundation of the world we thought we knew. The question isn't whether CERN scientists discovered a strange magnetic anomaly. The question is, what comes next? And will we be ready? Or will we watch as our magnetic sanctuary shatters, one ripple at a time?